Hello and welcome to a special interview for The Wire supported by Glenlivet Books. I'm joined today by one of South Africa's top scientists, one of the team that was responsible for detecting Omicron, as well as identifying its worrying mutations. So the two key questions I want to ask today is how was that detection made? And more importantly, how do South African scientists assess Omicron? I'm joined by a Senior Infectious Diseases Specialist at the University of KwaZulu Natal and a member of the Network for Genomic Surveillance in South Africa, Dr. Richard Lessells. Dr. Lessells, before I talk to you about Omicron and how you assess this variant, let me start by asking how you and your colleagues came to detect it. I gather that this happened around the 19th, 20th of November, when South Africa was experiencing around 200 cases a day. At that time, your team and you noticed that there was a sharp surge in cases in a province called Gauteng, which was both surprising and concerning. What happened thereafter?
Yeah, good morning. So I'll try and explain. So we have this genomic surveillance network in South Africa. It's called the NGSSA, the Network for Genomic Surveillance in South Africa. And we set this up in the very early stage of the pandemic back in February 2020 with funding from the government, from the Department of Science and Innovation and the South African Medical Research Council. And that was really because we knew in South Africa that tracking this virus and tracking the evolution of this virus was going to be critical to inform the public health response. And we knew that because we have experience with other viruses and other pathogens and how they evolve over time. So this network is basically a network of 7 specialist sequencing labs around the country that are all connected to multiple diagnostic laboratories. So the public and private laboratories that do the PCR testing to diagnose this virus infection. And essentially we tried over the course of the pandemic to get a kind of random selection of samples that test positive in the diagnostic labs, and we sequence them to see what's happening to the virus. And you might remember that about this time last year, we were one of the first groups to pick up one of these variants of concern, what ended up being called the beta variant. And that was because we'd noticed again, something changing in one part of the country, and a rise in new cases and a rise in hospital admissions. And we're able to sequence the virus and detect the beta variant. This time around, you encapsulated it nicely. We were sitting at a very low level of transmission. We were seeing very few cases, very few hospitalizations in kind of October, beginning of November. And we were kind of foolishly getting a bit optimistic that this year we might get a Christmas holiday and we might get a bit of a break from this virus. Of course, the virus had other ideas. One of the private laboratories in this network noticed that in one part of the country, Gauteng province, and particularly what's called Tshwane district, which is around Pretoria, one of the big urban centers, they noticed that they were starting to see more positive PCR tests again. But as well as noticing more positive PCR tests, they noticed something unusual about the PCR tests. And that thing that was unusual was this kind of signal called the S gene target failure or S gene dropout. And in simple terms, that just means that one of the mutations in this variant affects the PCR test, and it affects one of the 3 signals on the PCR test. So the PCR is still positive, it's still reported as positive, but you see this signal on it that there's something different about the virus. And because they were unsure what was causing that, they collected together some of those positive samples and they sequenced them. And they sent some further samples to our National Institute for Communicable Diseases. And they also started sequencing those samples. And the first 8 samples that we got good sequences from were where we saw this very different genetic profile. And we realized very quickly that, again, this was something new and something quite different to what we'd seen before.
Can I ask you this? How many days did it take between your first becoming aware that in Gauteng province there was a surge of cases and your sequencing showing up what was clearly a new variant? How long was the time gap?
I think around 2 weeks, but what's important is initially it wasn't really a surge of cases. It was quite a slow rise initially because we were starting from such a low base. But then there were a couple of quite big outbreaks in universities and other higher education institutions. And that's what kind of fueled then the more rapid rise in cases. So as we've seen throughout this pandemic, these kind of cluster outbreaks, these super spreading events that kind of kickstart renewed transmission in the community.
So the important point you're making is that because South Africa had a network of sequencing laboratories in place that were constantly random sequencing things, you were able to pick up a new variant, even though at that time, there wasn't really a surge as such. It was just good sequencing protocol that ensured that you were picking it up and you picked it up quickly. Have I understood that correctly?
You have, but the really key feature is that you're well connected to the people on the ground, to the clinical teams and to the laboratories on the ground, and that they can alert the sequencing labs and the sequencing network when they see something changing. Whether that's the rise in cases or this unusual feature in the PCR tests, we can then respond rapidly, get some samples and sequence them. So it's that kind of flexibility and that nimbleness that also really helps with the genomic surveillance.
Now, I believe thereafter, South Africa moved very, very quickly. I'm told that just 36 hours lapsed between your discovering the variant, confirming its existence in, I believe, hundreds of samples from Gauteng province, presenting it to key ministers, and then talking to President Ramaphosa, who very quickly thereafter went public. All of this happened in a record 36 hours.
That's right. There was a lot of speed at that time. That was partly because at the same time that we were picking this up in South Africa, our colleagues in Botswana, who we work very closely with, had actually also detected what would turn out to be Omicron in a number of specimens in people that had traveled into Botswana. And they had shared those genome sequences on what's called GISAID, which is the kind of platform that all of us use to share the genomic sequences. And this had already been flagged there by some international scientists as something that looked concerning and looked very different to what we've seen before. So there was the kind of chain of events was already rolling.
Okay.
But we knew it was important in South Africa to follow all our normal protocols for, as you say, informing the Minister of Health.
So, but you had useful corroboration from Botswana, and together you were able to very quickly and rapidly conclude that there was a new variant. Let's then come and talk about that new variant, because I think it was South Africa that first informed the world around the 24th of November, that this particular variant, B11529, as it was then called, Omicron as it's now called, comprised some 50 worrying mutations, 32 on the spike protein and 10 on the receptor binding syndrome. And that understandably created a lot of fear. Now, there are three real questions that need to be answered to understand just how worrying is Omicron. And I'll take you through each of them one by one. The first is, everyone seems to have concluded that Omicron is more transmissible than Delta or any other variant. But now the key question is, how much more transmissible? Do you have a sense of how much more transmissible it is?
I think that will take time to get a clear sense of that. What we see very clearly is that this is highly transmissible, and it's spreading very rapidly and very efficiently in a population that we think has high levels of immunity. And that immunity is a mixture of immunity from infection and immunity from vaccination. So actually, I'm going to take your question and probably what the second question is, because it's difficult to separate out what we think of as transmissibility and the other key property we think this variant has, which is immune evasion. We think that it has the capacity to get around some of our immune defenses, particularly what are called the neutralizing antibodies. So these things are important to think of together.
Absolutely.
Because when you...
On that second point, I noticed that there's a study that's been done by Juliet Pulliam, who's the director of the South African Center for Excellence in Epidemiological Modeling and Analysis. And that study says that Omicron is 3 times more likely to cause reinfections than Delta or Beta. Does that mean that this property, assuming it's confirmed and the study is correct, will enhance the transmissibility of this variant?
Exactly. In the context where you have many people with some immunity to the virus and from previous variants like Delta or Beta, and that's the context in South Africa. And you're quite right. This data, which again was produced very rapidly because this team have been analyzing the reinfections constantly, actually since this time last year when we discovered the Beta variant. So they could run that analysis and update that very quickly. And you're right, what it shows is what we predict when we look at the mutations, that this variant can get around the neutralizing antibody response, and therefore it is more likely to reinfect people who were infected in previous waves.
Absolutely. Now, I noticed that Professor Tom Wenceslaer, and I hope I'm pronouncing his name correctly, who's a professor of biology and biostatistics at KwaZulu University, has said that Omicron could have a 6-fold higher R value than Delta. Would you agree, or do you think that's still speculative?
Well, I think here it comes to this difficulty of working out the balance of what is the immune evasion lending to the transmissibility, and what is an intrinsic property of the virus that gives it higher transmissibility. So, for example, does it give higher viral loads in those that are infected, so they are more infectious? Or can you be infected with a lower dose of the virus, and therefore it's easier to acquire infection? These are the things that will take time to tease out. I think what you'll only kind of get an understanding when we see more data from other different settings outside South Africa, because there you'll get a better sense of this balance.
But you're flagging 2 things, aren't you? One, that the variant on its own is likely to be more transmissible than Delta. And secondly, the variant has another property, which is it is 3 times more likely to create reinfections. And the 2 combined suggest that it can spread much faster, but we don't know as yet about the high quality of viral load that it contains. That is still to be established.
So I think what I'm flagging is what I'm saying is that the intrinsic transmissibility may end up being not that different from Delta, or it may even be a bit less than Delta. But because of this capacity it has to get around some of the immune defenses, that means that more people in the population, again, are susceptible, because the immunity that they have will not protect them as well against infection. So it means that overall, the virus spreads more efficiently again, because there's fewer blockages to its transmission.
Absolutely, that's very, very clearly understood. And you've made a very interesting distinction that I hope the audience has heard between the intrinsic transmissibility of the virus and the additional quality it has of being able to get around people's immune defenses, which are a result of previous infection. The two combined will probably make it more transmissible than Delta, but just its intrinsic transmissibility may not be more than Delta. Possibly it could be less than Delta. One more question about transmissibility before I come to the second big issue. And that is, I noticed from newspaper and television reports that a number of people who are considered to be young and even considered to be children seem to have got it in South Africa from the reports. A, is it true that a disproportionate number of young people and children have got Omicron? And secondly, if it is true, what does that tell us?
So we're still getting a kind of clear picture about that. What was clear was that a lot of the initial spread, so those cluster outbreaks that I talked about, were amongst younger people, so in higher education and things. And a lot of the early spread was kind of in the 10 to 30-year-old age group in Gauteng. And it's only really in the past week or 2 weeks that we've seen it then spread rapidly into the older age groups. So what was noted by some of the teams here was that we saw a bit of an increase in the hospitalizations of younger people. And again, that makes sense because particularly the very young people, maybe some of the groups in the population that haven't yet been exposed to this virus, and certainly haven't been vaccinated, so they don't have any immunity to this virus, and so they're very easily infected with another highly transmissible variant.
But if I understand you correctly, you're saying it initially looked as if young people and perhaps even children, people around 10, 11, 12, were disproportionate in their numbers. But since then, it's begun spreading to older age groups, and that disproportionality doesn't stand out as much. Is that correct?
Yeah, that's right. It's not. So it's that it's not disproportionate. It's just the pattern of how the transmission kind of took off. That you got these cluster outbreaks. You got the spread in the most mobile, the population groups that are mixing the most.
Absolutely.
And it took time to then spread more generally into the older age groups.
Let's then come at this point to the second big question, which will help assess just how worrying is Omicron. And that is to do with the issue, does it lead or is it likely to lead to more severe disease? Over the last 2-3 weeks of experience in South Africa, what's your answer? Is it leading to severe disease, or are there widespread reports that it's not leading to severe disease? In your eyes, close to accurate?
So the reality is it's still early and we just don't know. And really this will be the most difficult question to get clarity on. And it will take some time. And again, it will take data from not just South Africa, but other settings to get a good understanding of that. And one of the reasons for that, again, is that we expect the profile of clinical disease to change over time as the pandemic continues, and as more people have built up some immunity, either from infection or from vaccination, then we expect that modifies the clinical disease that we see with these repeated waves of infection. And so what we're really busy doing at the moment is really disentangling the data and trying to understand to what extent it's the immunity that's modifying the clinical picture, as opposed to that there's something different about the virus and the variant that causes a different clinical picture.
Absolutely. That's another very important point, which I'll underline for the audience. You still need to distinguish to what extent is the immunity that people have either from previous infection or vaccination that is modifying the sort of disease they get, and to what extent is that modified disease, in fact, a product of the variant itself. But let me point this out to you. I noticed from today's papers that the South African Medical Research Council has published a paper, but apparently it's not as yet peer-reviewed, which clearly says that the majority of people in hospital with Omicron are quite happy on room air and not in need of either oxygen supplements or ventilation. Are those reports accurate and true? And secondly, if they are, is this a good sign?
Yeah, you're right. There's a lot of reassuring preliminary information coming out from the hospital doctors and the doctors in the community in Gauteng, who now have the kind of most experience, even though we're only kind of 3 weeks into this Omicron wave or so. That what they're seeing, they feel that things are quite different from the second and the third wave of infections. And one of the other important caveats to what you just said was that a lot of the people in hospital are actually not being admitted because of COVID, but these are people being admitted to hospital for, say, a surgical procedure or some other reason, and they're testing positive on admission, because we test everybody on admission to hospital. And so that's one of the other reasons why you would expect that some of those to have milder disease, because they're not coming in because of their COVID, and they may be earlier in the stage of the infection. And so that's why we've kind of been cautioning that, yes, a lot of this data is reassuring, and a lot of the reports on the ground are reassuring, but it is still early days, and because it's only recently started getting into the older age groups, we still do need time to get a clearer picture of the clinical spectrum.
One quick question: as things stand today, are South African hospitals under pressure, and your ICUs in particular?
So at the moment, not where I am, because in KwaZulu Natal, we're a little bit behind. We're a couple of weeks at least behind Gauteng. There is a rapid increase in admissions, and we are starting to see an increase in ICU admissions. But it seems that is at a different rate to what we've seen before. One of the other important things to note is that the hospitals are coming under strain a lot, because a lot of healthcare workers are getting infected and are then having to be off work to isolate or to quarantine because they've been exposed to a colleague or to a patient with infection. And that's a real concern, and we need to think about that very carefully. Okay. Because again, a highly transmissible variant that can get around some of the immune protection and still cause infection has the potential to cause a lot of problems to the health workforce. Absolutely.
And this brings me to the last of the three critical questions which will help us assess just how worrying is Omicron. We've talked about Omicron's capacity, which is said to be 3 times more than Delta and Beta, to break through immunity acquired from previous infections. So I leave that aside. I'm now talking about what I suspect is your hunch, because you probably won't have data. What's your hunch about Omicron's capacity to defy immunity from vaccination? What do the 10 mutations on the receptor binding domain suggest about vaccine efficacy?
So we need to get the real world data to understand how well vaccine effectiveness holds up. We have just last night released some of the preliminary lab studies that look at how well the antibodies neutralize Omicron in the lab. And they are, as expected, they show a big drop off in the neutralizing capacity. And this was looking at people who'd received the Pfizer vaccine, 2 doses of the Pfizer vaccine. One thing that was important just in these preliminary results was we showed that the people who had just been vaccinated with the 2 doses and had not previously been infected, they had a significant drop off, and many of them didn't show any substantial neutralization of the virus in the lab. But the people who had infection and then been vaccinated with 2 doses, they had a much stronger antibody response, and that antibody response held up better against Omicron in the lab. And that gives us some sense that people who have been infected and then vaccinated may be better protected, and potentially also suggests that people getting a booster dose, a 3rd dose of a Pfizer, for example, may also have adequate antibody neutralization.
I just interrupt there and underline something that you said, because I think that could be potentially worrying for many people hearing you. You've said that your laboratory tests have shown that people who've had 2 full doses of Pfizer but no previous infection, in their case, laboratory tests show that the neutralizing antibodies very significantly diminished. However, if in addition to 2 doses of vaccination, Pfizer is what we're talking about, you've also had a previous infection, then in fact the antibodies hold up pretty well. So when you say that there's a significant diminishing of antibody neutralization, how significant is that? I mean, how big is it? Do you have any sense of what we're talking about? Is it a 50%, 60%, 70% diminution?
So what we look at is kind of the what we call a fold reduction, and here the preliminary results show a 40-fold reduction. Now that's very significant because if we look at some of the previous variants of concern, the kind of maximum you were talking about was around maybe a 10-fold reduction in neutralization or so. So this is clearly kind of in a different league, but it's not unexpected to us. And those numbers are often imprecise because you're dealing usually with a very small number of samples. So we'll get much more data out over the next week or 2, and we'll get a better sense of the kind of average reduction.
But absolutely, but at the moment, even though it's preliminary data, we're talking of a 40-fold reduction in protection. Earlier, you said other variants had led to a 10-fold reduction. This is 4 times more. And as you said, this puts Omicron in a different league. This is surely not good news.
It's not good news, but it's not unexpected. And I think what we see is what we predicted we would see when we looked at the profile of mutations in this variant. And there's some very key things to kind of clarify here. So firstly, when we talk about the laboratory studies and this 40-fold reduction in antibody neutralization, sometimes people kind of immediately say, translate that to mean that the vaccines will be 40-fold less effective at protecting us. But that's not the case. And what's really critical is to understand that here we're only looking at antibodies and neutralizing antibodies. And they are just one part of the immune protection that vaccines give us. And you will know that the vaccines are designed to protect us from severe disease and from death. And that protection involves not just the neutralizing antibodies, but the other arms of the immune system, and particularly our B cells and T cells.
Yeah,
that's
so
right.
You're saying antibody immunity may be 40-fold reduced, but cellular immunity, T cells and B cells, will perhaps remain fairly good.
Well, we expect them to be affected much less than the neutralizing antibodies. And that's critical because that means that, yes, what we see in the lab and what we're seeing in the real world is that this variant will be able to get around the protection and still infect people. But the key issue is going to be how well the protection against severe disease holds up against this variant. And that's something that will take a little bit of time to really, again, see clearly in the data. Is it holding up as strongly as against other variants, or is there a bit of drop-off in that layer of protection?
Can I put this to you, Dr. Lessells? You've tested in your laboratories the efficacy of 2 doses of Pfizer against the Omicron variant. Have you been able to test for AstraZeneca? And I'll tell you why I ask, because AstraZeneca in India is called Covishield, and 90% of the vaccinations given in India are Covishield. So there's a lot of interest in this country to know whether you've tested against AstraZeneca, and if you have, what the outcome is.
So we don't have data yet on AstraZeneca, but there are many groups in South Africa and now many groups around the world all doing these laboratory neutralization studies. And we will, over the next few days, see all the different combinations of the different vaccines being tested against this variant. So the results from our colleagues here in South Africa, Professor Alex Segal, and it's his group that have produced these initial preliminary results with Pfizer, but those will be added to with the other vaccines. So we'll get a picture over the next few days and weeks of all of these things. But we expect it to be broadly consistent across the different vaccines in terms of the neutralizing antibodies, because that's what we've seen with the other variants.
One quick question, and I'll ask you for a short answer. Does your laboratory study suggest that boosters are a very necessary thing?
Well, they don't directly answer that question, because this preliminary data only looked at people who'd received 2 doses of the vaccine. But as I said, some of those people who had 2 doses of the vaccine had had a prior infection. And so there's some kind of extrapolation from that to say that it may be, if you have 3 doses of the vaccine, that may give a kind of equivalent response to 1 infection and 2 doses of the vaccine. But we need to see the data again. And again, there will be many groups working on with samples of people who've had 3 doses of the vaccine. So we'll see the data. We'll get a picture over the next few days and weeks.
One last question, and it's more out of academic curiosity than anything else. South Africa publicly announced that they had detected Omicron. I believe it was on the 24th of November. About 4 or 5 days later, the Netherlands suddenly said that they detected it on the 19th of November, but amazingly, they hadn't said anything to the world about it. They only went public after South Africa went public. And then in an interview to CNN, the president of Botswana has revealed that he believes Omicron came to his country when 2 European diplomats arrived there and tested positive around the 11th of November. So given what the Dutch have said about their country on the 19th of November and the Botswana president saying the 2 European diplomats brought it on the 11th, you get the feeling that possibly Omicron originated somewhere in Europe. It was only detected and amplified in South Africa and Botswana, but perhaps originated in Europe.
Yeah, the reality is we may never know, and you highlight this kind of challenge of working out where a variant first emerged. It's very difficult. What you will pick up is where it first starts spreading it enough that you'll detect it in your genomic surveillance. I think what you've seen is as with the previous variants of concern, that once it's detected and once it's kind of designated as a variant of concern, there's then a lot of extra sequencing. So there's kind of intensified sequencing all around the world, and people sequence many recent samples. And so the picture that you have initially changes a bit, and you start to get some samples that have been collected a bit earlier, as you say, from different parts of the world, and it helps you to build up a picture of actually where was this spreading the earliest.
Okay.
And that needs very detailed kind of analysis, what we call phylogenetic analysis, to kind of build the family tree of the virus and get a clearer picture of where it emerged. The key public health thing is that it highlights to us that that actually shutting off and closing borders to a few countries is largely futile, because this virus has already spread quite widely and is already spreading in the community in many parts of the world by the time you've kind of detected it and raised the alarm.
I take your point entirely, and it will be quite a while before we can fairly conclusively establish where Omicron originated, and indeed it's even possible we never will establish that. But I thank you for this interview, Dr. Lessells, and in particular for revealing the results that only emerged, as you said last night in South Africa, of laboratory tests, and what they suggest that in fact, after 2 doses of Pfizer, the efficacy of the vaccine is 40-fold reduced in terms of antibodies. But as you said, this does not mean that its cellular immunity will be affected, and its efficacy against serious disease is likely to stay quite strong. I think that is an important point.
So just a caution that we wouldn't call that efficacy. When we talk about the laboratory studies, efficacy is not the right word to use, because efficacy suggests how well the protection is working.
As you said, it's neutralization against antibodies, and I stand corrected.
Exactly.
Neutralization against antibodies is 40-fold reduced, but this does not mean that cellular immunity will be affected in any way like the same way. And more importantly, it does not mean that protection against severe disease is reduced significantly. I thank you for that.
That's right.
I'm very grateful. Take care, Dr. Lessells. Good luck with your work.
Thank you.
Stay safe.
Thank you very much.